another of our panelists, Dr. Craig Trester will not be available today. So we'll continue with that. So yeah, we have some time. I believe everyone is joining right now, and all the panelists, thank you so much for joining us today with your valuable time. So hello everyone, welcome to the panel discussion on sustainability and feasibility of biomaterials. Firstly, I would like to thank all the organizers of Darwin amazing event and the participants for their super enthusiasm. So if we want to talk a little bit about this session, it's important to understand the deteriorating state of the world and urgent need to switch to more sustainable methods. So biomaterials is
clearly. Yep.
Yeah, we can.
Okay,
See
great.
you.
Okay, so well, we don't have enough time, so I go over like my work. In this occasion, I want to present Be Grounded. That's the first one of these different projects. So in this case, I want to hint into this symbiosine. That's my main orientation in this project and in many projects. I want to lead to this era or time when we want to meet with the other, encounter with the other, whatever the other is, and complement with each other. No, so proposing an era of symbiosis with the other, collaboration and coexistence. So Be Grounded, this is Be Grounded. In this project, I wanted to explore the relationship between humans and other living organisms, in this case, plants, as an emotional and artistic manifesto through the textiles. And it proposes the exploration of a new habitable space in the form of a woven garment with growing sprouts. And it's more about that sensory and interactive experience itself. So it's not just about wearing it, it's not about aesthetics at all. It's about growing it, it's about feeling it, it's about feeling different new type of feelings, no, of senses. Well, I bring to the discussion this phrase about Melissa Maria Lindqvist, is an expert for encountering the vegetal being, where art is paramount in this investigation because it allows us to experience, feel, and perform or visualize these alternatives of beings, these non-humans. Through art, we can also experience how to engage with plants non-anthropocentrically. So it's to explore the unique place of their being and attempt to avoid the instrumentalization role that we too often assign to them. So I think this experience is something that clearly cannot be done through imagination. We cannot put ourselves into how it feels to coexist, to feel the symbiosis, to feel how it feels to be in touch with the roots of plants, for example. So I think it's so important to use or to implement art to explore different types of coexistence, no? Like just exploring different possibilities of what can be done and how we can feel, no? So some few images about the research and development. I built my tools, so I custom tools like loom and spinning machine to create the garments. And here, like in the right, you can see like how it looks like on the bottom with the roots. So that's what goes straight to the skin. Well, here the key that I mean, it's not commercial at all. It's just another perspective of the project itself, but it's everything that has the kit in order for this user to grow it, no? And here is for me very important, no? Talk to them, like trying to always generate some kind of interaction between. Then here you can see how I grow the material. In this case, it was winter, so I was trying to generate the optimal conditions for the garment to be grown. And well, here in the right, you can see different sprouts growing, and like I have many pictures of all the stages of the growth. And it's actually very nice to see, like, you know, the first day, maybe you don't feel like so enthusiastic, you cannot see anything happening over there, and then everything starts growing, and you kind of get involved like emotionally with it. Like it's super nice to see it growing, and well, with any plant, but I don't know, like not everyone is used to these things, so I think it's something good to point out. And well, this is my practice, material-driven design. So when design is guided by the materiality, you can give rise to infinity of alternatives and become like a new mean to extract an ecocentric present future. Why I say present future? Because I think it's like just coming soon. So well, there I think we need we have needs for new materials clearly, and we within these materials, they come to nourish us, to comfort us, to delight us, to cover us, or even like to keep us alive. So I think that combining different disciplines and techniques, we can reach the point to explore different materialities. And usually I think it's very important to have an iterative approach. So in that case, you intervene the materials or the raw material, I mean, with different ways, no? So as many ways as possible, and then you can just analyze your material properties and choose what direction to go. Within this, I said, I think the most important thing is about the storytelling and the emotional response of materials, because those are what hit us, no? Like what manifests things within us, not just the functionality, but also the emotions that it manifests in ourselves. So I think it's very important to rethink like the current methods we use, and in that way, like be able to reimagine, no, like the future we want to have. Well, I want to continue investigating and disseminating.
Big infrastructure. What we're looking now at is different feedstock. So the carbon comes from sustainable biomass. In the energy sector, it's interesting because you've got other alternative sources as well. You've got hydro, you've got wind, you've got geothermal, you've got solar. And it's not about which one is better. They all have to work together to ultimately be sustainable. And there is a very good point for bioenergy and biofuels. And what we've seen is the big role that now that we are moving away from exploiting more fossil resources, where biofuels has a role to play, is in the aviation sector. In the foreseeable future, it's very hard to see that long distance planes will fly with anything but with biofuels. In the marine sector, very, very hard to have an alternative. And in the sector of solid heat, like replacing coal, imagine if you would replace all the coal with sustainable biomass, that would be fantastic. But it's more than that. Like always, it has to work with the material side together. So energy alone is not the answer. So like every refinery, you need the high value products, the biomaterials that we're talking about, has to be co-produced with the bioenergy. And that's where biorefineries are absolutely critical. And they can be, it's great. By far more countries can contribute to that, because every country has distinct biomass available. And you can build a biorefinery based on nearly everything. You're not limited by a huge scale or huge size. And that makes it such an interesting area. So going forward, what will change is really this. We're still a carbon-based life form. We will need carbon, but what we have to have is the discussion: what is sustainable carbon? And that is biomass, that might be CO2, but also recycled material, and that all has to work together, both in the energy as well as the material side.
Wow. So great. I mean, well, I think like we can still have some hope for this bio-based energy and everything, because the way some of the people are like globalizing the matter in terms of economy, global economy, and all kind of like exchange values. So there are a notion going on, and there are like some ideas flying around. Okay, this bioenergy will take more time, or maybe this is just research. But coming from this expert, we now got a little idea, or maybe we can like translate it into a bigger idea. So the people who are researching on this bio-based energy, please go on, and we need you guys more than ever. So thank you so much, Grayson. Now, if we shift to Dr. Sangeeta Srivastava, and from your profile, we got to know your involvement in industry with a significant capacity. When it comes to replace any conventional product, industry, culture, and system will be involved, obviously. That may lead to research, right? So how can we design any process where certain industry academia collaboration will influence new generation learners to get involved in research to create nature-friendly technologies? So yeah, that's the question.
Very interesting. So you put in everything in one, so it's a big question. Yeah, absolutely. But the topic itself is development of sustainable biomaterials. It's very important, and as for our new generation learner, it is actually to be looked at as challenge, which is an opportunity, basically. So it's a challenging opportunity for the new learners. And based on my experience, what I can talk about, because I've been in this field from last almost 30 years, where we've been doing biorefining. And first, and the most important thing is understanding of the problem holistically. So once we understand a problem, for example, if it's an industry, I want to develop, I need a biomaterial for any of the uses which my panelists also talked about. But I need the material at the comparable price with the same or the better quality, and the product should be produced by using green and sustainable process. Now, this defines each and every aspect of developing and involving into the research, where academia can pitch in, and the new learners can think about, like, how do I make a product which was made by petrochemical, and now I want to do with the bio-based or biomaterial. Then it's like it requires a good understanding of chemistry, if you go by the first thing, and then you need to understand the scalability of the process, because any process to be having very economic value is, it has to have atom economy, where you need to understand the chemistry of it and the process which it goes through. I'm just putting myself only into the biorefining portion. Then you should also look at the scalability, because I can do any process in the lab, develop it, but is the process scalable? If I can't scale it up, then there's no use for the industry. So this is a challenge when it is, we should learn from the industry and try and see how we can scale up the process. And then the third very important part is sustainability. So any process we are developing has to be sustainable. So you look at our environment and see what we can do to make the product economically and sustainably. So here, industry and academia both have to pitch in with their learnings to make it happen. Now, development of economic and environmentally benign process for the scale-up production of materials which will be needed for the future, like chemicals and fuel, like biofuels, biochemicals. This is, I think, according to me, is the most challenging for the 21st century. And we are at the right place where we have a lot of opportunity, and we can, by understanding the problem, we can design our learnings, design our outputs so that it is sustainable for the environment, sustainable for the country where we belong to, or using the biomass which is generated at the particular location. So it could be very sensitive to the even location. So this is a way which I think we can design our process and learn from it. Thank you.
Thank you so much, ma'am. This was like, well, if I want to take a look at some of the world perspectives, like first world, second world, and third world, we know the industry structure and the labor and kind of research device. So from your insights, maybe we can connect them and like we can like map out in our mind, because I know many of the participants here, they are trying to initiate research, at least in this field, at least a couple of them, a percentage of them. So maybe they can take a direction from here. So thank you so much, Dr. Sangeeta Srivastava. Now,
Thank you.
you're welcome. And now, Ms. Joy Powell. So if I go through your profile and the work you are doing, I myself is an educator. So actually, we often find it hard to make great percentage of the population aware of the fact that many conventional products are not leaving an environment-friendly footprint when used. So how do you think community-level science education and design thinking can build the awareness about sustainability and importance of the biomaterials?
Thanks for the question, Salman. Yeah, I've been thinking about this a lot. I think really we have to start with the conversations within our communities. What are the problems that we're facing? What are the issues that we have day to day, but not just within our selves, within our human habits. It's actually what is happening in our environment as a total. So what are the economical impacts and what are the environmental impacts? We have to think about these things from say the SDG, Sustainable Development Goals. We have to think about them from an equality impact, an inclusivity impact, how accessible the education is, how accessible the knowledge is that we're dealing with, and also we have to think about the diversity in there. Too often it is left up to universities, the people who have access to universities and who have access to industry. In actual fact, in regards to the previous speaker's question, actually one of the models that is very interesting and is looked a lot now in circular economy and circular principles and indicators in different projects is actually downscaling, making the industry localized, making the education localized, exchanging data between places rather than setting up mass scale industries. So having a formula where you can do that, and that includes the education side. So actually being able to say, we want to have different locations where you can access, say makerspace or a lab space, and reach across to the local community and share with them that information so they have access to it. You may have a disability and not be able to access it as well. So it's many different areas that I think we have to connect to in terms of the level of science education. And if we want to think about any kind of other scale of using biomaterials, we have to work with the communities who will be using those products. Because if you don't do that, if they don't understand how to use them, then we are just creating designs again that will be just as bad. And we're not thinking about this in a way. And it's the same in regards to how we may dispose of those materials, thinking about the importance of that. So understanding that there is a life cycle within all materials, whether it's a biological loop or a technical loop, those kinds of understandings and building in those systems. And I think really also thinking about how we can not just not just the word of design thinking, but actually it should be reversed, and it should be thinking and design. We first think together, we think about what is the problem, we think about what solutions we might create, and then we design together. So really just pulling that apart and bringing it back together. We can't do this on our own, and we do need the impacts from the communities. And I don't just mean, you know, village communities and towns and cities. I do mean business communities. I do mean the networks and sharing that information together. You know, sharing what the legislation is country to country. I've been working on a project in South Africa, and I know that they use Australian and Austrian legislation for the biomaterials. The same for the project, Reflow project, that Materium is on. I'll share some links below in the chat. But the Reflow project is actually 6 different cities looking at a specific waste. And the specific waste is then boiled down into what are those components that are being impacted. Amsterdam, for example, is looking at textiles, whereas Milan is looking at food waste, and really engaging with the community to have these projects and bringing in the science, bringing in the design thinking within those larger projects that can be replicated, because the sort of like blueprint for how they're done and how they can be adapted to location or city or town is there and is accessible. Reading reports and case studies, these are the things that should be made more accessible and widely available to community members. And that includes the science side as well.
Thank you so much, Zoe. Well, there's a thing, I mean, one question is like coming to my mind, like we are talking about different nature-based system and also biomaterials. So one thing came just, you know, floating around, that is, if we want to replace with some of the existing business, because, you know, this plastic industry and many of the industries, they're like huge, millions and billions of even maybe trillions, I have no idea, that amount of money invested on that. So there are like labors involved, there are like technologies involved, there are industry, infrastructure, everything. So replacing those within a short period of time, I don't think that's a very feasible idea. Maybe like, I think creating a new culture or new ecosystem, we should be like thinking about how we can, you know, complement each other at the beginning, then we can like merge together at some point where no disruption should. I mean, I really am not very fond of this word of disruption. I think Laura can be like agree with this point. I mean, maybe coexistence and like putting it at a time, like meeting at the half point or something. So this is one thing. And also another thing, at the last part, we just got to know about the regulation and legislation. This is another thing, because from Florian Gracian and Dr. Sangeeta, actually, when we're working on industry, or maybe there are like many process and regulation we have to pass through for any sort of products. So this is another thing, because that sometimes, actually not sometimes, most of the time, that can depend on the government, even the connection with other governments, other countries, and how you are like transporting, what kind of labors are involved. So, and also the resources also. So, I mean, all things are connected. So if we want to bring a new kind of system, or if we want to research on some or invest on new systems or like processes, maybe we need to take those under consideration. And yeah, and I think we have time, enough time for the question and answer sessions, and I am already getting some of the questions. Now I really was looking for one question to ask. Like, I'm just like giving it here. If any one of you can take it, like, how can citizen scientists contribute to enrich database of biological objects with industrial or ecological value? So this is just an open question. If anyone wants to take that, Florian, Laura, Ms. Sangeeta, or Zoe, or even anyone from the audience. So this is an open question.
Can you repeat the question
like
again?
write it
Sorry,
down, I guess.
Salman, it just
Yeah,
broke
sure.
up there.
Yes, of course. How can citizen scientists contribute to enrich database of biological objects? For example, like fungi and anything with industrial or ecological value. I'm gonna like write that question here. Or if any of the audience or the participant, if you guys have any question, please write it down. Our panelists, we can like have the question for answers.
I think in terms of how they can contribute, I think is just basically to get involved. You know, I've been working with a biomaterial specialist in South Africa and having discussions about how it can impact his local communities. And we're talking about some very liminal, very rural communities who have a lot of agricultural biomass. Just being able to say, you know, what is a local biomass waste, just being able to say that what is possible for for the region where he's living, what the soil needs, what the nutrients are there that are involved, and how they can stay within that biological loop, how those nutrients don't have to be, say, burned because they're an agricultural waste, or transported somewhere else because they've become a waste. I think these are really important. And so just to be able to get involved with your knowledge and be open to others' knowledge, you know, as Sangeeta mentioned, see it as an opportunity. And I think that that's really important.
Thank you so much for taking the question. So, well, here, actually, there are like lots of discussions, and we have many eye-opening perceptions from all the panelists here. I'm sure like these amazing panelists have a lot more to add, how effectively they are being able to connect with concerned areas. So now one thing, we may stay connected and exchange views or collaborate. So I would like to request our panelists, or even if anyone is interested, you can put your social links or even business links or websites so that people can connect with you. And any one of you here, Florian, Lara, Zoe, and Dr. Sangeeta. So do you have any particular projects going on that you want to share with us here today that's relevant to today's topic? I mean, I'm sure like you have already, but maybe something special. Anyone?
So may I add something? Yeah.
Please.
Yeah. So very interesting is like today we talk about developing the biomaterials, and what I have seen and understood is any kind of development, it's very site specific, because the biomaterial or biomass or any feedstock which we have in a local area will be very different than any other feedstock. So what is required maybe as a kind of a database where, you know, we can identify, okay, this feedstock, this particular organism can work on it. It's like just throwing the idea. So it's like you can do differently. So suppose today we are working on bagasse, which is a waste from sugarcane. So when we use bagasse, we have a different set of microorganisms which can work on it. But the moment we use corn or something else, a different microorganism works. And also even it depends upon when I'm doing in south or north. So these are challenging things, and definitely like a lot of it can be put in database as well. Whatever learnings we get from our way of doing research or way of doing business, like when we have our farms where we do grow sugarcane, each farm is a kind of a field of innovation, because we can put different kind of like a fertilizer, micronutrients, which can help us to get what we need. Do we need more biomass? Do we need more sugar? And do we need a crop which can run with less water? So these are the areas which are really challenging. So when we start looking at our local area with our inquisitiveness, and we find a lot of challenging place where we can do innovation. Yeah.
Thank you so much, Dr. Sangeeta. So another thing, I mean, I was thinking about bioeconomy for a long time, and I can see in the chat, this word is like playing around. Well, how do you think here, Florian and Laura, I think you can put some light on that, because the way we're trying to introduce nature in a different way with science, to integrate with different technologies. So actually, nature was the first thing that we have been using from the very beginning. So it's not like we are trying to bring back, I mean, introduce the nature. It's kind of like we are going back, or we are trying to adapt this natural process. So how do you think our bioeconomy, or this concept, or reshaping some of the aspects of the economy or the global economy can help us to get more involved into these nature-inspired projects? Again, I'm saying it's not like we are introducing it. It was there. It has been always there. We are trying to repurpose it, or maybe we are trying to reshape it with because time changes and the needs are changing, the population growth and everything. So maybe bioeconomy can play a big. What do you think? Do you have any light on that? Anyone here in the panelist would like to listen to that?
Well, I didn't hear your question completely, but I have some glitches in the sound. But for bioeconomy, and also adding to what Zoe said before, I think it's very important to, in the first place, it's not about just like sustainability, like keeping ourselves growing and existing. So what we need actually is to think about others as and the planet, as well as we care for us. No, so in terms of design, and here like adding to what Zoe said before, if we start thinking, I mean, if we start designing the material itself, then we can scale it up and design the product or whatever we want to do with it. So first, starting from designing the material, then you can scale it up to whatever you think. Obviously, starting with local resources, so designing with local raw materials, and then as a hint to, I mean, to empower the citizens as well. So before you ask something about with industrial ecological value, and I think the important thing about biomaterials is skipping a bit the industry, no? So biomaterials is something people can start playing with it without being within an industry. You can start within your kitchen. You for example, the last project I've been doing is called En Desuso. So in English would be like in disuse. And with food waste that I saved from different restaurants here in Barcelona, I create a series of lamps. So if we can empower the citizens with all these open source recipes to generate their own products, let's say, like to cover their own needs, then it's just about pushing it further to produce not just locally but individually as well within your area, and avoiding the thing of mass producing, of mass wasting, of in the end, like we are producing much more than we can consume. And in that way you can also produce something that maybe, well, actually it can happen in many kind of recipes. For example, in this same project, I built some lamps that you can, for example, you don't use it anymore or something broke, you can just melt it or like blend it and build it again, no? So it's something about giving a longer use of the matter, no? So exploiting the matter as more as you can, and don't need to consume. That's like kind of industry values. So I think it's the most important thing is to empower the citizen to be able to create their own things, not just feel like they cannot do something. They can, like, it's in the industry is so much like covered in a way so that people don't kind of get into it. They don't build their own things. So I think it's very important to share recipes, design locally, well, I think that's it. And design from the material, thinking about the use you want to give to that object or whatever. Obviously, if it's an object you want to be there for, I don't know, 1 year, you don't need to build something with a material that's not that won't biodegrade after that. I mean, so that's my opinion.
Thank you so much. Anyone wants to add something to that?
I think it's really good what Laura just said in terms of the life cycle of the materials. It's so important that we think about that, and also the life cycle of the systems. A lot of people are putting a lot of work into developing new tools and new materials, and the thing is, we have to think about the systems where they're going to go into, how they're going to be recycled, how they're going to be used by the user or the industry. And I have some agar samples here, and it's really interesting to say that, like, you know, if I make one sample, okay, it's more like a craft level. But if I have 3 different samples, actually, then I can analyze them, I can compare them, I can see the data from that, and I can think about how useful they're going to be within the industry and going forward. And, you know, we do have to think about plastic packaging for, you know, our uses and our habits that we need to change. But for example, we can start to think of potential alternatives, but maybe it's also about how much, exactly as Laura said, how much we use, how much we consume, and just starting to build on this, but not having the initial test, you're not able to do you know, anything with them. And I think you're not able to, you know, carry that further. I think within also industries, there are some amazing things going on with like biorefinery now and biofuels, and one of the byproducts actually can be glycerol or glycerin, which gives flexibility. Now, it's not virgin glycerin, potentially, you know, it needs to be tested, and all of these things are experiments. It's always ongoing research, it always needs to be tested. And then actually thinking about, you know, how can we use those byproducts? How can those byproducts also have a value? So it stops being about sustainability and trying to sustain the level that we are at, and actually about regenerating and making a plus product, a product which actually has value afterwards. It's like everything can be upcycled, everything can have a more positive impact, and we just have to go through those iterations. You would never tell like an art student, you know, or a, you know, school child not to explore their art materials and express their creativity if the only materials they have access to are you know, some hand-me-down acrylic you know, crayons, which maybe are not so sustainable anymore. But you would want them to express themselves, and you would want them to develop, and maybe, you know, go on to using something else, and they start to look at the plants in their garden to be able to see, you know, what they can express their creativity with. So we do have to have this transition, and I think that's okay, and I think we just have to be wary of it and not think everything has to change immediately, but we do have to give more understanding to everyone.
Yeah, maybe
Thank you so much. Yes.
from our end, what we, because we're working with a lot of big international companies, and we are working with them like the principles we've put together for them as like 6 R's. So first of all, you refuse. If you can refuse anything, you will do that. You reduce, you redesign, you recycle, you renew, and you repurpose. So and with that, you kind of have a certain hierarchy, what you work through. And that's this transitioning to circular thinking. You don't just use sustainable materials and ram them into a linear economy. So that's one element. And the other one is with our partners, we're not using the terminology waste anymore, because waste doesn't exist in nature. And it is simply that concept of symbiosis, and symbiosis thinking is so critical in that new type of economy, that we refer to it now as side or as byproducts. And everything has to be reused, and otherwise that system and cycle doesn't work. So there is, I know it's challenging, but looking at the biggest global corporations, there you won't find credible companies anymore that don't have sustainability targets and very strict targets. So yes, it's a journey, but the speed of change is remarkable. And if anyone believes they can't do that or can't follow that, they will be out of business faster than they can think.
Sure, thank you so much. And now we are at the end of our session. So thank you so much all the panelists, Zoe, Laura, Sangeeta, and Florian, and also all the organizers and all the participants. And maybe this, discussion can go on, but here we have to give the place for the next session. So thank you so much, everyone. So we're gonna wrap it here. Bye. Bye, everyone.
Bye. Thank you.
Thank you so much.
Bye-bye, thank you.
Have a nice day.
Thank you.
Have a nice day,
Bye.
everyone. Bye.
Take care, everyone.
Bye.
Thank you so much to all the panelists for coming in here today. It was a pleasure listening to you guys. All right, so moving on to our next session, which is the breakout session.